Today I will talk about fuzzy logic. This is my second lecture on fuzzy mathematics, and this is part of my series of lectures on decision making. First, I will give introduction to fuzzy and fuzzy logic. Then I'll talk about fuzzy logic architecture. Then I'll state advantages of fuzzy logic, and then I will give an example of Python code of fuzzy logic. The phrase fuzzy describes something that is unclear or perplexing, whereas in Boolean logic, the truth values of variable may only be the integer values, either 0 or 1. Fuzzy logic is a many-valued logic form in which the truth values of variables might be any real number between 0 and 1, including 0 and 1. So this is an illustration I've taken from this site. In Boolean logic, there are only two possibilities, either yes or no, whereas in fuzzy logic, there are many possibilities in between 0 and 1. Fuzzy logic is a term used to describe the concept of incomplete truth. It is employed to handle the concept of partial truth, where the truth value may range between completely true and completely false. In real life, we may encounter a circumstance in which we are unable to determine if a statement is true or false. The fuzzy logic technique mimics how humans make decisions by considering all of the possibilities between digital values true and false. Although fuzzy logic had been studied since 1920s as infinite valued logic, Lotfi, a professor in California, coined the phrase fuzzy logic in 1965. He realized that traditional computer logic was incapable of dealing with data that represented subjective or ambiguous human concepts. Fuzzy logic enables users to develop or create nonlinear functions of arbitrary complexity. Any system that is logical can be simply fuzzified using fuzzy logic. Fuzzy logic works with membership values in a way that mimics Boolean logic. I have described in detail about fuzzy sets and fuzzy numbers in my previous lecture. A common replacement for basic operators and or not is called Zade operations. And these are the operators. So corresponding to and in Boolean is minimum of membership function of two fuzzy sets in the same universe of this course. Or function is corresponding to max function or max operator in fuzzy sets, and not operator is equivalent to 1 minus membership function. Then fuzzy logic architecture. There are three types of fuzzy inference systems: Mamdani systems, Sugeno systems, and Sakamoto systems. In Mamdani fuzzy systems, there are three steps. First one is fuzzify all input values into fuzzy membership functions, then execute all applicable rules in the rule base to compute the fuzzy output functions, then defuzzify the fuzzy output functions to get crisp output values. So this is a beautiful illustration of Mamdani fuzzy inference system I have taken from this internet resource. So this is how we combine two inputs to get an output, and finally we aggregate these uh, fuzzy outputs to a crisp output by defuzzifying the output. This is the illustration of fuzzy logic architecture. So it is a rule-based system with an inference engine, and there is input which is fuzzified and output after defuzzification. This I have taken from this internet resource. So fuzzy logic architecture have four things. It has a rule base, then it has a fuzzification, then there is a defuzzifier, and there is inference engine. So rule base. The if then conditions provided by experts are used to regulate the decision making system, and the rule base is a component used for storing the set of rules. So it is the rules are provided by experts, and fuzzification is an input transformation module or component that turn crisp numbers into fuzzy sets. There are largely three types of fuzzifiers: singleton fuzzifiers, Gaussian fuzzifiers, trapezoidal fuzzifier, or triangular fuzzifier. I have talked about triangular fuzzy numbers and trapezoidal fuzzy numbers in my previous lecture. And this is about fuzzification. Fuzzy sets are often defined as triangular or trapezoidal shaped curves, as each value will have a slope where the value is increasing, like this increasing value, a peak where value is equal to 1, this is peak, which can have a length of 0 or greater, and a slope where value is decreasing. So this is a decreasing slope. So this is a trapezoidal fuzzy number. They can also be defined using sigmoid function. Then another component of fuzzy logic architecture is inference engine. It enables users to determine the degree of correspondence between the current fuzzy input and the rules. Then defuzzification. Defuzzification turns the fuzzy set inputs supplied by inference engine into a crisp value. A common algorithm is for each truth value, cut the membership function at this value. Combine the resulting curves using the OR operator. Find the center of weight of the area under the curve. The x position of this center is then the final output. Then advantages of fuzzy logic. Fuzzy logic concepts methodology works in a similar way to human reasoning. The framework of fuzzy logic is simple to grasp for any user. The concept is straightforward because it is based on set theory in mathematics. When compared to traditional methods, fuzzy logic takes less time to design. The fuzzy logic system's flexibility allows any user to simply add or delete rules. Because the technique may be simply represented with little data, it does not require a huge memory. Now, example in Python language, I have taken example by this author on heart disease risk. The link of this code by this author is given here. So first we import skfuzzy. skfuzzy is part of scikit fuzzy library. Then we also import membership of skfuzzy, and this is for graphical representation, and this is for the array manipulation. So first of all, we define the universe of discourse. So these are the definitions of universe of discourse for these variables. So these are input variables, and the risk is output variable here. So this is an example of universe of discourse for age. So age range from 0 to 100 in our present example. Then we take input from user. So this is the code for input. From user, we take input of a particular case, and we will match the values with our rules. Now, the variable age is divided into three parts using this code. So, as the young individuals here, then middle-aged individuals, and older individuals. So there is overlapping because this is a fuzzy logic concept. Then this is variable blood pressure. It is divided into four levels: low level, middle level, high level, very high level. And this is how we fit the present case input to these levels. So we have fit into low level, mid level, high level, and very high level. Then this is the variable cholesterol. It is divided into three levels: low, mid, and high. And this is how we pick the current input of case to low level, mid level, and high level. Then this is variable blood sugar. It is divided into just low and very high. So then this is fitting of the present case value. Then this is the variable LDL. It is divided into four levels. These are the levels. And this is fitting of the current case with these levels. Then this is variable HDL, and it is divided into three levels, and this is fitting of current case SDL value to these three levels. Then this is the output variable, and it is stratified into no risk, little risk, mid risk, high risk, and very high risk. So these are the risk levels as output. Then these are the set of rules. For interested viewers, they can go to this site of the author who has described these rules for the present scenario of heart disease. Then this is the output. So we find here as maximum because there is the concept of OR operator here. And this is the output of our present case. So it has predominantly a lower risk as well as it has this high risk, a little bit of high risk. Then, so this was our present case. Case was aged 49 years with blood pressure 136, cholesterol 200, blood sugar 100, LDL cholesterol 157, HDL cholesterol 38, and coronary heart disease diagnosis risk is 14.46. So this is a crisp output here. So this is all for today. Thank you very much.